Okay, here's a second video on graphing a quadratic relation using the X-Intercepts. So it's just another example. This one's a little bit trickier. That's just not as nice numbers in this example. Same process though. So the first thing you're going to do is find the X-Intercepts. So I'm going to find the X-Intercepts. So we'll do that by letting y equal to 0, or substituting y equals 0. So let's make that look like a 0, not a 6. So 0 is equal to 2x squared minus 5x plus 3. Now we're going to factor this. So here's one reason this is a little bit trickier. It's a little harder to factor. Well, the good news is 2x squared, well, we know it's got to be 2x and x, assuming it works. And then the last number multiplies to 3. So just listing those numbers. We know it's got to be 3 and 1. It's just a matter of deciding which one. Actually, this number is negative, so it's got to be negative 3 and negative 1. So it's just a matter of deciding which one gets which number. So if we multiply diagonally, 2 times negative 1 is negative 2, and 1 times negative 3 is negative 3. If you add those together, you get negative 5. So that's our combination. So we want to multiply 2 by negative 1. So we'll put it in the opposite bracket, and 1 by negative 3. So I'll put it in, well, the only other spot. Now I just need to solve this. So this bracket, 2x minus 3 equals 0. This bracket, x minus 1 equals 0. So we've got 2x adding 3 to both sides. 2x equals 3, divide by 2. X equals 3 over 2. And over here, if we just add 1 to both sides, we get x equals 1. There are two X-intercepts. The second step would be to find the axis of symmetry. So that's just the midpoint of your two X-intercepts. That'll be where your vertex occurs. So all you're going to do is your axis of symmetry equals, add the two X-intercepts and divide them by 2. So if we add 3 over 2 plus 1, let's just get a common denominator on the numerator. So 1 becomes 2 over 2, and that's all over 2. Right? So I just turned 1 into 2 over 2. So we've got 3 over 2 plus 2 over 2 is 5 over 2, and that's all over 2. The way you divide fractions, you take the numerator, change the division to multiplication, and the reciprocal of the denominator. So that's going to be 5 over 4. So your axis of symmetry is 5 over 4. Maybe I'll just start my sketch right now. So remember, rough sketch of the curve is all we're really doing. So here's my curve, my x, my y. My x-intercepts were 1 and 3 over 2. Alright. So let's make, okay, that'll be 1. That'll be 2. So one of my x-intercepts was at 1, and the other one was at 3 over 2, which is just right there. 3 over 2 is really 1.5. So there's our two x-intercepts. We got a axis of symmetry of 5 over 4, which might help you if you can't see where that number is. It's actually at 1.25. So that's, well, it's obviously right down the middle. So it's 1 1/4. So right there. So now we just need to figure out the height of where our vertex occurs. So our third step will be substitute x equals 5 over 4 into your original equation. Just remind myself of what that was. 2x squared minus 5x plus 3. 2x squared minus 5x. Was it plus 3? Minus 3? I forgot already. Plus 3. That's y equals. So I'm going to put this in for x. 2 times 5 over 4. 5 over 4 squared minus 5 times, well, 5 over 4, not 4 over 5, plus 3, and just work out what this is. So 2, do the exponent first, 25 over 16 minus 25 over 4 plus 3. We can simplify this first thing a little bit. Right? Remember, this is 2 over 1. 2 and 16 have common divisors of 2, so it become 1 and 8. So 25 over 8. Maybe at the same time recognize that I need a common denominator now of 8. So I'm going to change this 4 to an 8, which I do by multiplying by 2. Multiply this by 2. Becomes 50. Plus, this one's got to go over 8 too. So 1 times 8 is 8, and 3 times 8 is 24. So 25 minus 50 plus 24 would be minus 1/8. So that's y. So therefore, vertex is, my x value was 5 over 4, and my y value is negative 1/8. If you want, because you're plotting this on a graph, some people prefer the decimal. That'd be minus 0.125. So 1.25 and negative 0.125. So, well, let me just write it up here. So 1.25 and negative 0.1.25. Okay, so 1.25 is right here. And let's say this is negative 1. Negative 0.125 is just below the x-axis. I mean, I'm being very, very rough with my sketch. And then you've got that's your parabola. Just connect the dots. So just by graphing those 3. Okay, so it's another example. A little bit trickier just because it's a little harder to factor, and you end up getting uglier. Well, you get fraction X-intercepts, which means you have to deal with the fractions, but you know, it's the same procedure.